Here's another example of rectilinear motion, again using the integration approach to it. If a of t is equal to 4 feet per second squared and v at time t is equal to 0, v at time t is equal to 0 is negative 6 feet per second, find the displacement and the distance traveled between t is equal to 0 and t is equal to 6. Okay, so let's see. So what we want to do, it says then draw the graph of the function of the velocity function and shade the region that represents the displacement. Draw a graph of the velocity I guess it should be the speed function here. Well, I guess the velocity function, and sketch a region that represents distance traveled. So let's see. So a of t is equal to 4. So v is going to be the antiderivative of a, or the antiderivative of 4, which is equal to 4t plus c. And we know that v of 0 is equal to negative 6. And v of 0 is the velocity function with each instance of t replaced by 0. So it's going to be 4 times 0 plus c. And so equating these, we have negative 6 is equal to c. So then v of t is equal to 4t minus 6. So v is going to be 4t minus 6. The displacement is going to be the integral from 0 to 6 of the velocity function 4t minus 6 with respect to time, and that's going to be 2t squared minus 6t from 0 to 6. And so this will be at time t is equal to 0, it's 6, I'll have 36 times 6 squared, 36 times 272 minus 36. All right, and at times t is equal to 0. All right, this will, I have 0 minus 0, so that's just 0. So this is going to be 36 feet is the displacement. I think, let's see if I have that. I was supposed to calculate down here. And oops, I have 24. I thought I'd fix this. 36 feet is the displacement. All right, the distance, well, the distance is going to be the integral from 0 to 6 of 4t minus 6 dt in absolute value. It'll be the integral of the speed. And so let's see, 4t minus 6, that's going to be equal to 0 when t is equal to 3/2. Adding 6 and dividing by 4 is equal to 3/2. So we'll have to think about this as the integral from 0 to 3/2 of the absolute value of 4t minus 6 with respect to time, plus the integral from 3/2 to 6 of 4, I should say the absolute value of 4t minus 6 dt. All right, now, of course, let's see, between 0 and 3/2, say at 1, all right, this is going to be negative, so this would be the integral, change the sign, 3/2, that's what the absolute value will do, of 6 minus 4t dt, plus, say, at 2, that's between 3/2 and 6, so that this will be positive, all right, 4 times 2 minus 6 is positive. So from 3/2 to 6, all right, the absolute value is going to do nothing. Okay, so let's see, if I calculate the antiderivative, I'm going to get 6t minus 2t squared from 0 to 3 halves plus 2t squared minus 6t from 3 halves to 6. Now let's see, when I evaluate this at 3 halves, let's see, I'll have 6 times 3 halves is going to be 9. And 3 halves squared is going to be 9 fourths times 2 is 9 halves, so minus 9 halves. At 0, we'll have 0, so it'll be 9 minus 9 halves. All right, plus, let's see, at 6, this is going to be 72. 36, 6 squared is 36 times 2 is 72 minus 36. Okay, minus, okay, when I evaluate this at 3 halves, I'll have 9 fourths times 2 is 9 halves, minus 9, 6 times 9 halves is 9. So this is going to be 9 halves minus 9 halves is 9 halves, minus 0, still 9 halves. So plus, in here I'll have 72 minus 36 is 36. All right, and then 9 halves minus 9 is negative 9 halves, so I'm subtracting that, so we'll have plus 9 halves. And then 9 halves plus 9 halves is 9, plus 36 is 45, so there should be 45 should be the distance. And I think I must have been half asleep when I wrote those in. So that's going to be the distance. So let's take a look at the graphs here. Here's the graph of the velocity functions. -6, notice it crosses at y half. So this would be the displacement. Notice this part would be negative because it's below the x-axis. This would be positive. Okay, negative and positive. All right, and then this would be the distance. All right, well, we change the sign where this is negative, and then all of this would be positive part. So if we added those two areas together, we'd get the distance. All right, let's take a look at this. So suppose we have this velocity function. Find the displacement and the distance. All right, on the interval from t equals 0 to t is equal to 3. All right, well, in this case, all right, the distance and the velocity is positive, so the distance and the displacement is going to be the same. So we would have this as the distance would be 3 times 1 is 3. Would be, actually I should say that would be the displacement, and since it's positive, 3 would be the distance. For this one, same thing, except now I would get a negative displacement because the velocity is negative, so negative 3 would be the displacement. All right, the distance would be positive 3. All right, in this instance, all right, the displacement, well, I have positive a half of a unit, negative a half of a unit, negative another half of a unit, so it would be negative 1/2. But the distance, well, I just add these up. 1/2 plus 1/2 plus 1/2 would be 3 halves. Okay, the displacement here, well, I have 1/2 plus 1 is 3 halves, and then I have two areas that cancel one another out. So this is going to be 3 halves. All right, the distance traveled will have 1/2 and 1. Then I'll have 1 times 1/2 times 1/2. 1/2 base times height. 1/2 1/2 times 1 is 1/4. And a 1/4 here. So 1/4 1/4 is 1/2 plus 1/2 is 1 plus another 1 would be 2. So that would be the distance traveled there. Remember, distance traveled is going to be the absolute value of to integrate the absolute value of the velocity or integrate the speed.